This tutorial will cover some of the more advanced functions of the lathe, including threading, grooves, and the use of multiple tools, and the tailstock. Before attempting this part, you should have completed the first two sections of this tutorial, as well as programmed a few cycles on your own. The previous tutorials have given you a step-by-step process, but this one will only give you a general overview of the tasks and a few pointers. You will need to draw on your experience as a machinist to fill in the details. Here is the item that you're going to be making, your very own lightsaber. There are two components to this job: the handle and the pommel. The handle is made from aluminum, and the pommel is made from brass or steel to serve as a counterweight to the blade. The SolidWorks files and drawings for these parts are available in the link in the video description. You can download them and customize the design however you want. There's no one right way to manufacture a part like this, but there are some good rules of thumb. For example, during machining, we often approximate the part as having a fixed geometry. But in reality, no material is perfectly rigid, and the stress of the tooling process will always cause the part to flex by a small amount. This leaves a thin layer of material behind and makes the part slightly larger than indicated. The degree of this flexing is a function of the material used, how deep the cut is being made, and how long and thin the part is. For a short and thick part, like the top in the previous tutorial, this flexing is negligible, especially because the top was an aesthetic component and didn't need to conform to any tight tolerances. But on the lightsaber, because it's longer, the flexing can be on the order of a few mils. In addition, there are interior threads cut on the end of the handle for the pommel to attach to, and an error of a few mils is more than enough to prevent threads from fitting together. Because of this, it would be a good idea to cut the threads first before removing the rest of the material from the handle. This will keep the component as rigid as possible when the threads are cut. If that isn't enough, you can retract the part deeper into the jaws and make it stiffer, though that will take time and it might induce errors if you re-zero your tool incorrectly. Are these trade-offs worth making? Well, that is a decision you'll have to make as a machinist. Another important aspect of good machining is good tool selection. For example, the right-hand cutting tool that we used when we made the top is a good default tool. It has a thick, rigid cutting surface and can take deep and fast cuts off of components without breaking. However, because of its shape, a right-handed cutting tool can't reach down into deep grooves or interior faces. For example, how would you machine the groove of the thumb grip with a right-handed cutting tool? You can't. To machine features like this, you'll need to use a groove tool, or a button cutter. But these tools are thinner and more fragile, so they can't take as deep of a cut or work as rapidly. Is this feature worth the extra time it will require to manufacture? Well, the answer to that question will depend on your experience as an engineer and your priorities as a machinist. How valuable is your time? How much wear are you willing to tolerate on the tool? Is it more economical to go back to the drawing board and design the part so that it can be manufactured without this feature? These are all important questions that a good engineer will think about during the design process. A good compromise in this case might be to machine the biggest chunk of the cycle with a right-handed cutter, and then come back and complete the groove with a second cycle and a button cutter. What about the hole running through the middle of the handle? Well, this feature will be machined with the tailstock. The tailstock accepts drill bits and end mills just like a milling machine, but unlike the carriage, the head is fixed in the X direction and is only free to move along the center axis of the lathe. This lets you drill holes along the center axis of the part. You probably won't have a drill bit long enough to go through the entire part, so you'll need to turn the part around and drill it from both ends. The pommel hole will also need to be drilled with the thread's minor diameter before being threaded. There are two ways to do this. You can use a drill or an end mill on the tailstock, or you can use a cycle or boring event on the carriage with a boring tool. Interior cycles like this work just like exterior cycles, but they begin on the lower right corner and proceed clockwise instead of counterclockwise. Which is the better method? Again, the answer to this question will depend on what tools you have at hand, how accurate the cut needs to be, and how valuable your time is. There is no one right answer. The tailstock can also be used to stabilize a long part. Replace the drill chuck with a live center and bring it up tight against the part. Lock both the tailstock and the feed in place, and the part will be securely clamped from both ends. Let's take a quick look at the two new types of events which this program contains: threads and grooves. Threads are cut with an interior and exterior single-point threading tool by moving the tool in a series of Z passes at a constant feed rate. An encoder in the spindle head allows the carriage to always begin each pass at exactly the same point, producing a continuous thread. An advantage to this is that the process can be paused and restarted reliably without the need to realign the tool with the beginning of the threads. As long as the part is not removed from the vise, the machine will always remember exactly where the threads begin and end. Thread events require the following specifications: X begin and end, which is just the major diameter of the threads at the start and finish of the cut. For most threads, these will have the same value. Z begin and Z end specifies the Z edges of the threaded region. Pitch is the distance from the crest of one thread to the next, which can be computed as the reciprocal of the number of threads per inch. Spring passes are another way to avoid the problem of the part flexing during machining. A spring pass is a Z-cut at the minor diameter of the threads, which is repeated multiple times without changing depth. It clears the threads of chips and reduces the amount of material left over by the flexing of the part. Plunge angle is the angle that the carriage will move at when it first begins threading. This is standardized at 29.5 degrees for most threads and can usually be left at the default value. Side determines if the threads are interior or exterior. The number of starts is the number of channels that run along the thread. Most threads have a single start, but you can manufacture more if the design calls for them. The RPM should generally be kept low, no higher than 500 RPM or so while threading. A groove is a simple type of cycle with only 3 sides. Most of the values are self-explanatory. The indices on the coordinates refer to each corner of the groove moving counterclockwise. The repeat function can also be used if there are multiple steps with identical geometries, like on the grooves of the handle. Select the steps you would like repeated, and then indicate by what increment and in what direction the repeat should progress. For a large piece like this, where a lot of material is going to be taken off, the coolant can also be used to keep the part from overheating. Turn on the spray by pressing the accessory button on the control panel, and regulate the flow of coolant with the valve on the nozzle. Once you feel comfortable with these features, you can customize your saber in the lathe any way that you want. The blade can be made from wood, plastic, or whatever material you have available, and locked in with a thumb screw. Got something else you would like to build on the lathe? Give it a try. The best way to become more adept on any of these machines is to attempt a project on your own. Talk to any of the shop staff or the TAs if you have any questions. Thanks for watching these tutorial videos, and have fun!